Good morning.
Hi, everybody.
Hi.
Hey.
Good morning.
Morning. Sophia, how's Berkeley?
Going well, going well. Busy, but it's going well.
Oh, good, good. Sometimes the shock of college campuses can throw you off, but you were prepared, I think.
Yeah, it's just got to get through it. Midterms start again next week, so getting ready for those.
Okay, yeah. Well, I'm glad you can make it to the meetings. This is great. Okay. Let's see. Looks like we've got a pretty good representation. We got to go ahead and get started. I'm hoping that Mark was able to get things pulled together, but he had a very bad week at work, a lot of long hours, so he may not even be able to come. But
And I've got a few things I'd like to talk about sometime.
yeah, well, let's go ahead and you got the talking stick.
Okay, first off, Dave just sent an email out. He says he won't be able to meet us today.
Right.
Okay, so one of the things that I was been discussing with Russ, specifically to the known binaries project, is our ability to make a user-facing interface or location for the data that's actually being obtained on the 1 meter and the 24-inch, and for that matter, any observatory or telescope that we happen to go to. He has a specific kind of file structure he's looking at, and that can be totally independent currently of what is being done by Nick on the NINA side of things. But it would be our ability to bring that data down to some local, I want to call it local, location where we can let students or us or whoever get into that particular data and manipulate it. We'll bring it down, do analysis, prepare to write papers, which is the big end point here. We want to make sure we emphasize. So everything necessary to do that. But to do that, we got to have some kind of a web presence somewhere where we can do that. And I don't know, Pat, do you already have a current web presence where we could do things like database manipulations and generate pages that users could go in and work with?
Not exactly. However, I have an Azure account that I can apply that I've not. Are you familiar with Azure?
Not specifically. I know it's Microsoft's way to do basically cloud interfacing.
Right. Yeah, and it's I have that available to me, and it might be the right thing. I just don't know much. I don't know. I would not be able to handle the IT end of it at all.
Okay.
That would be one thing, because my other interface is a server that I have here, which I wouldn't necessarily want to just make it wide open to the universe.
Oh, no, that's not what I'm suggesting at all. In fact, it'll be totally only exposed and visible to users that we have defined, students or members of our team or whatever it is.
Yeah.
Not publicly facing. It won't be anything accessible to anybody unless they have an account. In other words, it would require a login.
Okay. Well, that's manageable. I could look into either one of those. I think my IT guy would recommend the Azure account, just because he seems to like that a lot, and it's fairly robust in terms, and it's also pretty reliable. But I just don't know much about it. So
that'd be great if you could talk to your guy and see what he recommends.
And can you how much data do you think there'll be?
Well, it depends. What are we going to bring down? What are we going to archive? What are we going to keep? I mean, we've talked about this before. We got this flood. Rick is smiling. I like this. We got this flood of data about to come down, based on Nick's wonderful, plugins and stuff that are there, and we need a place to store that. We need historical references somewhere. So, gosh, I don't know how big we expect that to be. If it was me, I would probably spec out like 20 terabytes or something like that for the end result. I mean, it's going to be pretty big, but to start with, it'll be fairly small. And we can decide on what it is we need to actually archive. We may not need to archive each individual image. We might want to, maybe just the cubes, maybe the results. That's something to kick around, but I would make sure you got plenty of space, or at least space to start with that can grow. I mean, if
Yeah.
we can do that, that'd probably be the better way to do it.
Well, there's no question. I have a Dropbox account that has no limit. So
That's dangerous.
no.
But the bad part about Dropbox is, in order to use that data, I have to have a Dropbox as big as yours, or else I can't get the data down.
Can't you just set up yours so that it's online only, so on your end, and then it doesn't have to, except for what you pull down.
Well, we'd be talking about all kinds of students getting into it and that type of stuff. So they again have to have some way to bring it down. So I'm kind of leaning away from Dropbox. I mean, it's a great tool.
Kalei is saying she's got a Google Drive with no limit.
Yeah, and that for sure you can share with students who are limited, because I've done it many times.
Well, that'd be kind of cool, certainly to start with. Maybe we can investigate that some more, Kalei. And Pat, do see if you can talk to your IT guy though about a permanent solution. We don't want to have to burden, Kalei or somebody else with this long term. We want to make sure it's, kind of going to be around, and your foundation set up, I think, for that kind of stuff.
Yeah. So, what kind of interface are you thinking about? Are you thinking sort of an SQL database, or what?
Well, we'll put a database up there to hold stuff, but it's mostly file structure. Putting files, the files down that people could then navigate and get to where they want to do. A lot like is being done currently on our interface to the telescopes down in Chile right now, similar to that.
Okay.
And we could generally, I mean, it'd be pretty easy to whip up some form pages that would allow the people to go, select what they want, extract what they want, and bring it down local to their drives.
Okay.
Play with.
How many would
Pat,
be
doesn't-
uploading? What's that?
I was just gonna say, it seems to me that Bark is pretty well suited to do what we're talking about here. You do certainly have to have adequate memory, but memory's cheap, and
Yeah,
and all the functionality is certainly there.
yeah, that's why I need to talk to. I may need to upgrade the machine to get enough to handle 20 terabytes. I know I'd have to.
Well, that was just a guess, Pat.
Yeah.
I mean, we're going to start out slow, and if we can let it expand and build, that'd be a great way to do it.
Okay, let me. I'll take that as an action. I'll look at the options here and get back and see what makes most sense.
Sounds great.
Who would want to manage? Would you be able to manage the database software aspect of it?
I don't see why not. It'd be, fairly simple to do to start with, and again, we'll let it grow.
Yeah.
Yeah, I could do that on my end. That'd be fine.
Okay. Okay.
The other topic is specifically about file structures. What Russ and I have been kicking around talking about, and we're going to move ahead with our particular part of it, is we're generating a file structure that is capable of going from excuse me. Think of this as a hierarchy. Okay, so you've got the kind of media, maybe it's your server, maybe it's a SD card, I don't care what it is, but you've got some kind of media that you're going to put this on. Then you're going to have a project by name. So example, known binaries project, which is what Russ is really interested in. That would be the next level down. Then down below that, we would put in the site. Where did that come from? Is it from the 1 meter down, on a plane wave instrument? Is it from Mount Wilson? Is it from, the Discovery Telescope or whatever, that would be a site location. And then down below that would be the date of the data. When was that put there? And then down below that would be the specific target or targets, obviously, targets for that particular day on that particular system. And a general notes category where we could generalize the data. In other words, the night was cloudy, the night was clear, we had cirrus come in, it snowed, I had to close early, whatever it happens to be, and just a note structure. And that's the kind of hierarchical structure that I'm going to be setting up for Russ to play with right now. And I've already started generating a really simple Python tool to generate that entire structure based on what you put in. Very simple. So that's already in the works. But I don't know if we want to extend that further to all the projects. I think that would be a wonderful file structure to be able to use for any of the projects we're going to do. Eclipsing binaries, exoplanet, whatever it is that we actually go after for our particular research. And again, in support of generating papers. So down the road, I can see us creating some kind of a, matplotlib sort of graphing function that lets you generate specific graphs for your papers that you're going to want to put in. I can see all this stuff coming down the road, but it's going to be slow growing, and we may just change our mind in the middle. It won't really matter. But those are the kind of things that we're talking about doing right now.
I don't, there's nothing about, or is under site data, is there something about the telescope camera, anything of that, anything about the operator, any in the file structure, or is that something just more local?
That's a great comment. I think what we ought to do is make it so it's usable for, about any condition we can use. So if we want to include that type of stuff, we certainly can. The scope parameters, the cameras, I wouldn't go down to much level below that because it's all in the FITS header from each one of the images.
Yeah,
So,
right.
yeah.
Yeah.
The current structure that is produced by the plugin was thought up a while ago, and that's actually the structure that the bispectrum analysis also uses. So if we change the structure completely, then we need to change the program as well.
Yeah, and I don't want to suggest we do that to start with, for sure, because we can go in and grab that data any way we want and bring it down to our particular file structure. So I wouldn't even think about that right now, Nick. I would go ahead and continue with what you're doing for the automatic exposures, all the things that we're doing now. That's a lot of work.
Of course, it's not a lot of work to change the structure a little to that it if that works for the bispectrum analysis as well, then it's no problem. We just if we think up a good structure, then yeah, well, by all means we can change it.
Wonderful.
What about Nick? If you looked at it and thought through that we've got an existing structure from bispectrum, and then taking what Tom's talking about and adding that to the target list, just do an addition, so you don't have to change anything other than adding that data. Would that make sense?
But what would you want to add to the target list?
For example, you've got projects sort of right now, I think, in the file structure. It doesn't have site that I know of.
Right. It
does have, you have date in there already. You have
and all the targets.
Target in there already. So
Yeah.
we're talking about essentially.
Yeah, I think what we have in the Google Drive is a separate document for all the site data and the filter data and all the different things. But that's in a separate, just a document that goes with the telescope.
Right, and that's what
It's
I was thinking.
effectively at a higher level, right? The telescope source.
Yeah,
At the top level.
So, yeah.
But if you had in the record, I'm thinking in the targeting record, but maybe it's just the bispectrum output. Someplace it also indicated site. Then you have a relational database that you can tie in that telescope data separately, so you know it was at that site, so you can go to that site and pick it up. And then you don't have to maintain it in two places. Does that make
Yeah.
Well, another thing to think about though is we're going to be expanding this. We're not just going to be relying on specifically, Nina and Nick's interface to
true.
that in the future. We might, there's different camera software for collecting the data, all that. So,
Yeah,
if I think of the implementation down in Chile right now as a site and a specific site. I could see that being the same thing for, let's say, Mount Wilson. We go there a lot, right? It's it's a little bit different structure,
yeah,
and it's kind of like each individual project area would have their own place, and we don't need to modify this to be super generic, because then you cause more trouble than it's worth, trying to get all the parameters in and stuff. I mean, I don't have a problem with it being site specific like Nick's got right now, which is great. And we can just grab that data, what we want, and bring it down into that store we're talking about on your server, or, or whatever we decide to put it on.
okay. And basically the server is going to be just a data repository, not a, or is it going to have more functionality?
Well, yeah, it's going to have a web interface
Yeah.
that specific users with credentials can get into and
Right,
extract data.
right, but they're not going to be doing processing on the server, just to be a repository.
Right. I mean, everybody's going to want to process themselves, and I think that's kind of to Mark's point. He wanted to see what everybody does differently, and
Right,
we want to be able to bring it down in our own little basket. Maybe it's on my workstation. I do my stuff. I generate some graphs or maybe some reports out of it. If we want, we could send that back up to a special area for that particular project.
hmm,
Like building the document for the paper that we're going to actually produce.
right. Yeah, under that project area, okay.
I
One
can handle
more
your
level,
database.
one more level of definition might be the filter.
Yeah, I was thinking the same
At
thing.
the lowest level or near the bottom, just because even if you do all, speckle with the same filter for all your targets for forever, you still need to define what that is and make sure the database, it's easy to determine what it was.
Yeah, I mean, that's the way you do selects anyway from a SQL
Yeah.
database. You just
Yeah,
put
that's
your
already-
criteria in, bring down your data, and you're good.
That's already part of what Nick has in place.
Yeah, we don't want to make it so students have to learn SQL. That's not the point. The point is we'll generate some forms that let them fill out what they want and get the data back,
Right,
like all the big repositories now, for example, AAVSO, and they're set up to where you can go in and you can select criteria and you get a result in a comma separated value file or whatever format you need to bring it down in. I think
okay,
it's going to be really exciting. I think we can get a lot of good information going, and we'll refine this as we go. It's kind of like our project to date. It
Mhm.
started out, simple, and it's just gotten really, really well defined. I think that's a good deal.
yeah.
Those are the kind of things I wanted to talk about.
Yeah,
So,
that's good.
and I'm looking for that input, Rick. Like you said, filters, all that kind of stuff. We'll make sure that the structure of the relational database, it will enable all of that stuff. We can get that, for example, off of the list that the target list we currently put up there, or we can get it right from the FITS headers or the images that are stored on the server or whatever. So lots of ways to get that data.
One thing that's taken up some time for me is to define at the, I suppose at the FITScube level, a more complete definition of, like, including target and filter rather than just a generic, well, it's all there in the folder structure now. But at the FITScube level, it just says, okay, this was the time and something, because all that other structure is above it.
Mhm.
But when you want to process data and have unique names to do sort of more like a batch process, then you need more extensive file
Metadata.
names, which is kind of an issue. I go in and redefine the FITScube names, because otherwise they're all the same and they'll well, it's an issue.
Understand. Okay, so we need to have better
and yet
metadata about the cubes.
that makes things pretty cumbersome if you don't need that separate definition. So maybe there needs to be an option for it somehow.
Our solar siblings pipeline has a really good file naming convention that I've found very helpful. It has the files with target, filter. I forget the name, I can send it to you, but one important property of it is that the files, the default order is by timestamp. So having that preserved is really helpful, because then you can quickly get like if you put, sometimes if you put the filter first,
Yeah.
then it's going to be by filter, not by timestamp. But sometimes you might want that, like all the ones from the blue filter ordered by time, and then visual filter ordered by time, and whatever. But
Right.
yeah, so thinking about how it's going to show up in the folder, I think, and what the main applications will be, or but it's super helpful when the files are named in a way that makes sense.
You know, one thing we can do to meet Rick's requirement is we can post-process those FITSCube when they're taken and generated. As soon as they're generated, we can actually go in and modify the data on the FITS header for them, or maybe even create another small text document that describes all the metadata we want about that one, and then rename that FITCube so it matches the structure of the file name that people want. I agree with you, Rick. If you get a generic thing that says, FITCube, what good is that? I mean, you got to go in and figure out what it is, and you got to look at the data behind it.
Yeah.
And
And
the
the
FITS
data, the name and all the details are in the FITS header, but it takes time to go in and look at them, and it's error prone to copy and paste and whatever you want to do.
Yes, yeah,
I think-
that's
I think
an automation.
That's where it really needs to be programmed in.
Yeah,
That's-
that is a post-processing like you're suggesting makes sense. I don't think Dave will devote the time to be able to bring that into STB.
No, right. I can see him just saving the things the way they are now, and then we could have some triggers on the folder structure when it gets filled in to go in and modify things we want. That's a separate process. We don't have to get Dave involved in that.
And having the option to put those parameters in the order you want, like Kanai was saying, that sometimes you want a time series of data, sometimes you want a filter series, sometimes you want an object series, put them in the order you want. That might be a good functionality to program for the user on the website.
It's certainly there for selecting the data they want. That's an easy thing to do once we've got a database set up with, containing the metadata and also the actual some of the final result data, or however we want to put it in there.
Yeah.
We can certainly do that. That's pretty simple.
Okay. Yeah, Kalei, the OSS file name is very functional and useful. I agree. It goes on, but I think it's probably too detailed for the level of that we're looking for here, because it's got into air mass, and it has a specific camera that it was shot from. It has the Julian date. It has the UTC date.
Yeah, all that can go into metadata in the database. I mean, there's no reason not to do that, and you can select it any way
Okay,
you
well,
want.
let me share. I've got a thing called the decoder ring for that. I'll share it. For us old guys, we know what that means. When I say it, they don't know what I'm talking about at all.
Requirements for comprehensive and simple are kind of
Yeah.
self-exclusionary.
Yeah. Okay.
So honestly, the only field that I've never used from the OSS convention is air mass, because I always get that from the header info. But like, it seems like there have been applications where I'm like, wait a minute, that was the ones we took back in October. And so then I can go look, and like, since the UTC timestamp is in the file name,
Right.
I don't have to go and look into the actual files. I can find them quickly. And then sometimes I'm like, oh, I want the ones in the B filter. So like different parts of that file name, like even though it's horribly long and complicated and icky, like I've used those fields, and having them in the file name is helpful.
Yeah, we use them to know without having to dig into the FITS header. One of those there is exposure. it's in there as well. And, but, you know, I don't know if you want to, I'll share it and see what you think in terms of what fits into a metadata sorts of database.
Great.
Okay.
But yeah, if you
Could,
guys think, go ahead, Nick.
I could easily change the file name pattern as well for in Nina to if you want more stuff in the file name itself. I could put all kinds of things in there. So
Okay. Yeah, that's that would be helpful. I know, well, the functionality is very much the same for all of us, I think, is that if you have multiple users on one system, you need to be able to identify. That's where I was getting into the username thing. But I ran last night, I ran Barrow with modified header, slightly different than what you said, Nick, and it appeared to produce the right file structure, the forward structure. Yeah. Okay. Well, that's a hot topic.
I think that's great, but and it's honest because this data flow is just going to get nothing but bigger, especially if we start going other places. And you know, Dave puts the 1.5 meter up pretty soon, and the 2 meter after that, or we use the Falks north and south. You know, 2 meters or I mean, LCO. We go across the country, right? I mean, across the globe, and we got all this data coming in.
Right. Understood. Okay. Oh wait a second. I did. Geez. I in once. Mark did make it, but then I lost him. I hope it's not a rainstorm. There he is.
Oh, there he is.
Yeah.
Hey, speaking of going places, like that segue. So I just wanted to see, is March in Mount Wilson a thing? Like, should I put that on my calendar, or like, are we gonna try this out there? Or what are people thinking about that?
Well, I, for one, Calais, are going to start spinning up with Russ about some local observatories in the Arizona area, and I'm going to be implementing that networking system there to test it all out, see what's going on, and continue to build it better and better. So yeah, I'm ready for whatever we want to do, and I'm certainly going to be able probably to help at Mount Wilson or any place else we go within reason.
Within reason.
Yeah, to me, it's all driving. I don't fly.
No chili, huh?
Yeah, not anymore. I haven't been down there for a long time. So,
well, we had talked about the date of March 25th, and at the last InStar meeting, we were mentioning that, and Reed was like, well, we've got to pick a date. So I was wondering, have we picked a date, or do we need to talk about that more? I have that date free. That's the one that Sophia and I overlap in our breaks. But given that I don't have any of the equipment, I didn't want to like sort of make that hinge on my availability. But that would work for me. Does it, like March 25th? That's a Saturday.
It's just one night.
Just the one night, I think.
we have 2 nights, don't we? We have 2 nights banked.
I think so. InStar does, and I think that, well, Russ can speak to this perhaps, and Sophia. I think like at least one of those 2 should probably be used for a run with students. This would be an engineering kind of run. Or I assume maybe people want to bring students. I wouldn't be able to bring OHS students because the school has an event that weekend that I would have to miss to come. But if other programs wanted to, I think that would be a good thing to do. Or it could be an engineering run like last year. Or basically just want to figure out if it's something that we should move forward with talking to Tom Menegini about that date or not.
Yeah, I would suggest we move forward in that.
Sorry, what dates again, Kelsey? Kylie.
Well, so the date we mentioned last time was March 25th, which is a Saturday, and it was the only considerations that went into choice of that date were that my and Sophia's availability overlapped then. So maybe there's some other considerations that they would want to, throw in there. Sorry, and I didn't mean to cut you off, Russ. Go ahead.
Oh, no problem. So one of the things we talked about earlier was Rachel and Paul McCudden were very interested in recruiting a bunch of students from the, kind of the upper Los Angeles area there, so Paul used to be a community college teacher there, and he knows all the community college folks. And so we wanted to do that, provide him with some scholarships for kind of the Southern California students that we have money for. And so it would be an in-star, night for, so we'd be not only an engineering run, but we would have students. And we might have other students that would go. So I would vote in favor of making it a student affair too.
Oh, so you're going to make it a real scientific research project where they get to see all of our mistakes and see how we correct them.
That's it. Yeah, Tom, you and I had a real dilly the other day, didn't we?
Yeah, we had a lot of fun.
I think I'd be able to make it, although I don't have any equipment anymore.
You've got the
You'll have to
knowledge, though.
check
You've
in
got
with-
the knowledge.
Well, you have to check in with Reed, see if he can come and bring the camera and stuff, but yeah, that sounds good. My only concern is that maybe Tom already has that night booked for people, more off the street coming up if it's a dark moon. But he may be able to move it also to a week before or after, and still have a pretty dark moon for the visual observers.
Well, we should ask for it before it gets all filled up.
Yeah.
So wait, what is the phase of the moon? That
Just looking it up.
yeah. It says it is a crescent, so
Ooh,
it would
good.
be pretty dark.
That's good.
Yeah. So should I email Tom or okay, so I'm gonna write that down as an action because I'm gonna have to go early once again. So I'll email Tom about March 25th. Like not an engineering run, but like one of our nights, one of the in-star nights that we have sort of banked up. Okay.
If Tom already has the system wrung out a little bit in other observatories, then it's much more likely to work at Mount Wilson because he's been there and kind of knows what's going on there too.
Yes, sir.
Mhm.
So the plan would be to do some speckle runs that night.
Yeah, and I'm taking a screenshot of everyone here so that I can copy everyone here.
Yeah.
Here.
Well, for that, I would be planning to drive to California. So
Myself as well.
Yeah, I see it's 30% moon illumination on the 26th, the 27th, 40%.
25th. We were talking
26th, the
about.
26th is 30%. Yeah.
No, but did you say 25th, 25?
Oh, no, 25 is 20%.
okay.
Yeah, so 20% illumination, 20%.
So it's going up 10%.
Yeah,
Perfect.
yeah, if your system works, as I was mentioning, I've been talking to some people at Lick about maybe doing something there too. That would be later in the year, more information coming, still working it out with the school. They have lots of crazy rules, like really crazy rules. Don't get me started. I need to I need to take off early, but I'm gonna send this email later today. I'm copying everyone. 25th, 20% moon illumination. One of the instar nights, Rachel, and I'll copy Rachel and Paul. I don't think I have Paul McCudden's email address. Does anyone have it? And I can copy it down.
I think it's on the distribution list for my emails. And I don't,
Okay, I'll find it.
Yeah.
Copy
And
Rachel.
that would be an all-night session, Saturday night.
Oh, thank you, Sophia. I could stay for till midnight.
Well, I mean, not everybody has to be up all night, but
Yeah.
does Instar want to invest a whole night or a half night?
Oh, that's a good question, Rick.
And it's one night, right?
Right. That's my, well, Russ and Sophia, what do you think?
the moon sets at about midnight. Just
But the
after-
moon's pretty dim, so it's not going to affect speckle anyway.
Yeah, I think there's funding, I think the question might be, we might want to do it on 2 evenings, not just one evening and go all night. All night, I think we've learned is a little bit painful,
Yeah.
but people like to stay up there and do things. So maybe 2 evenings, and who knows, Tom might let us run a little late.
Exactly.
It would make my ability to, work any problems out we got with our networking and stuff as well, if we could, do that.
Yeah, and Tom and I, Bob Buckheim and probably Richard Hart. So anyway, we're going to work on getting telescope time here. So Bob and I are begin going down to Tucson shortly to talk to the folks that run the telescopes down there. And anyway, we'll try to get something going here, probably mid-December or January.
Mhm.
Mid-December would be good for students. January is, kind of away from Christmas break and so forth. And at any rate, we want to get kind of the Arizona Mount Wilson thing going.
I would suggest that we, if we do 2 nights, that we do Friday and Saturday night, because then Friday night could be engineering, the 25th, and then Saturday night could be a student night, which is easier for them, I think, rather than Saturday, Sunday, which wouldn't work as well.
Yeah, so that would be 24th and 25th.
20, I think 25th and 26th, right? The night.
26th is Sunday night.
Oh, 26th is Sunday?
Yeah.
Oh,
Yeah.
okay. So it'd be 24, 25. Yeah.
24th.
Are we all looking at 2023?
Yeah. Yes, 25th is on Saturday.
Yeah, that's right. Okay, 25th Saturday, so it'd be 24, 25. So the numbers I gave you were wrong. I was looking at the 24th is a 13% illumination with a moon set at 10:43, and the 25th is 21% at 11:50.
Mm-hmm.
Okay.
And the night, it gets dark a couple hours earlier than in the middle of summer, so we got a couple of bonus hours.
Yeah, we do. It's just a question of whether he's going to have, because it's pretty close to the new moon, whether that's going to be a problem.
Yeah, the previous week would be a really dark moon, so the crescent wouldn't rise till 3 o'clock in the morning, so you wouldn't have a problem with shifting that visual night of another week, I wouldn't think.
It's a little harder for students, I think. If we're in, because
All right.
there's
Remember, we shoot pretty much at the meridian, so we're up there.
Yeah.
Well, I guess all we can do is ask, huh? Let's see.
Yeah, okay, and I will send that later and copy everyone here who was here, and I'll have to go now, but it was great seeing you, and look for an email from me later today. And more information to come about Lick in June too. Thanks. Bye.
Bye.
Thanks, Glenn. I see, Mark, yeah, you're on.
I'm on.
Yeah, were you able, with that hard week you had, were you able to do anything as far as?
No, I've actually had a worse week this week. I'm
Okay.
at my wit's end, honestly. That's why I was so tired last night as well. So
Oh.
I've been working 18-hour days again.
geez.
So and even at the weekend, I had to do a presentation for to the CEO on Monday. So it's like I just had no time.
Yeah.
But I will. And I think next week, I mean, I've gone from I think I explained to you, Pat, I had like one person in my team. Now amazingly, I have 3. So so it's gonna improve, but I'm just frustrated because I spend my entire day analyzing spreadsheets and doing similar kind of mental work, and then my brain is worn out.
And Dave will be on next week, he says, probably, so.
Yeah, so that hopefully will be good timing. I mean, my promise is there. I'll have this research done,
Okay.
the analysis on this project done. So it's just a matter of time.
Okay.
Yeah.
I understand.
I'm hoping this weekend I'll actually have some my own time to do some. So that'll be huge. If I can get it going this weekend, I'll have it ready for Friday. So
Okay. Good.
I have some results on the photometry if anybody's interested in that. Since
Sure.
Mark isn't quite ready with the big show.
Yeah, I want to hear it.
Yeah.
Yeah,
Okay.
please.
Let me share and
Oh, yeah, let me share. Let me give you that. Where did that daggum thing go? Oh, there it is. Okay. Why are you hiding out on me? I can't. Maybe this. No. Just give me a second here. I'll find that. I don't know why I'm not getting it.
Rick,
sorry.
Rick, if you start to share, I think he pops the box up for.
Oh, wait, I think I found
enable.
it.
oh,
Found it here. There it is. Okay, share screen. There we go. Now you should be able to do it.
okay, there we go. Yeah. Okay, here's a spreadsheet that I'm using to analyze the data. And let me start off with, in case there's some of us don't really have a grasp on what's going on with all the corrections you need to do for photometry. I'll kind of go through this slowly, and if I'm going too slow, tell me to speed up. Basically, there's 2 major steps to doing photometric transformations. One is to characterize the atmosphere, how much light is absorbed and what are the colors, by whatever atmosphere you happen to be looking through. And then second, the filters, how well do the filters and the sensor and the optics and everything else match the original standard, which is the Sloan SDSS survey, and or the Pan-STARRS version of that, which they also have some pretty crisp data. So the basics of the absorption of the light by the atmosphere. This is a plot of extinction versus wavelength, and you see that the extinction is really going up like crazy as you get to shorter and shorter wavelengths, mostly because of this little thing, Rayleigh scattering. The wavelength of the light becomes closer and closer to the size of the molecules in the air, nitrogen and oxygen molecules, the O2 and N2. And then as you get to the ultraviolet, the O3, the ozone starts to take over and stops everything, which is good for us, so we don't get radiation burns every day. But then there's this aerosol, which is a sort of I don't know, I guess it's dust, very, very small scattering stuff. So all those pile onto each other and absorb light as a function of wavelength, and this solid black line is kind of a nominal high altitude amount of absorption. And the red dots with uncertainties on them are, I believe, are the sort of some of the groundwork that went into the APAS survey that Tom was involved with. Who was the guy? I forgot his name already. That made some observations from, I think, New Mexico. He has an observatory there. I can't remember his name, but anyway, I think these are his data. And it's kind of funny. There's a little lump of O3 that kind of produces a funny bump on the curve. But anyway, his data matched very well with the theoretical model. So that's good news. Down here at the bottom are the Sloan filter wavelengths of the original survey. Now we don't have a U filter, but that's kind of special purpose, and I think it probably could be used at the LSOS site very well, but going in, we chose not to use it. So the G is a pretty wide filter, about 150 nanometers. R is a little bit less, but and I is a little bit less, and then Z is typically a long wave pass filter. But I believe that the Botter filter that we have at the 1 meter is actually a cutoff there. So it's actually about 100 nanometers in the infrared, from about this same region, 820 or 830 out to 950 or thereabouts. I'm not certain about that, which one Dave bought. I think Botter makes 2 of them, and the old Astrodon filters had 2 or 3 versions also. Anyway, that's kind of background information. So the bottom line is here's the more or less center wavelength of the G filter. So that's a G measurement, and R and I and Z, and you see that there's a kind of a level, which is the basic absorption, and then there's a slope that's changing continuously. So the way that typically photometric corrections are made is to account for this level and the slope, a linear slope across the wavelength, and ignore basically the curvature of that region. It's pretty flat out in here. It's becoming important in the G, and it's very important in U, but typically it's ignored. Now I think Arnie would probably have ways to attack that also, but I'm not going there. So basically the goal of this first step of determining the extinction characteristics of the atmosphere on that night is to say, okay, what's the level of each of the filters, and what's the slope? Well, how much does it change depending on the color of the object? That's kind of what the slope means. Let's go back over here.
Where do you put in the camera efficiency? Obviously, the camera response changes considerably over the wavelengths. So,
yeah, it does. And that pretty much comes out at the end.
Okay.
We can't do much about it until the very end.
Okay.
These are the equations I used, and let's go through that. The goal of the determining the extinction and the process you use to correct the data is to try to get the color, the magnitude in each filter as though it were outside the atmosphere. Okay, so that's denoted by the 0 subscript, outside the atmosphere. The small letters with no, well, these small letters are all instrumental magnitudes for now. That's all we have to start with, right? What did our camera record? The K is the level, the so-called first order K prime extinction coefficient. That's magnitudes per air mass. And then the X is the air mass. So you multiply, to do the first correction, you multiply the magnitudes per air mass times the air mass. The second order is like the slope of that extinction curve, and it depends on the color of the object. So you have to have the G minus R. I've chosen the difference in magnitude between the G and the R filters. And the reason I did that is not because they're far apart, but because they're high signal to noise. That's where the camera's the most sensitive.
Rick, the G magnitude or the instrument magnitude, is that reference to is that to a reference star, or how is that?
For now, it's just the raw
counts
counts in an integrated aperture, and take the log of that and multiply it by minus 2.5, and that's a magnitude.
Convert it to magnitude.
It's just a raw instrumental magnitude. It's not corrected for anything yet.
Okay.
But going in, that's the only thing we have is raw instrumental magnitude. So I'm trying to get that to be the key in all this transformation work. What I have done before is to use the known fully corrected real instrument or real standard magnitudes. But if you do that, when you have a new star that nobody knows what the magnitude really is, how do you start? You can't you can't know it. You can't know it until you can use APAS. You can use something a measurement that someone else has made. But I chose to try to make this work as raw data from the get-go, and then eventually, hopefully, fully correct it with that start.
Rick, one thing to mention though is your raw instrumental magnitudes still have all the standard calibration processes done on all the images. So, dark subtract, flats, everything you normally would do to get you those raw instrumentals.
Right. For speckle work, I've chosen not to try to do flat corrections, but only dark subtraction. So everything I'm going to show you has been dark subtracted. And Nick kindly added the dark slide in as a standard pattern in the photometry mode, and it works beautifully. So we take a dark of the ROI, which has already been centered because of the plate solving, and or if that failed, then he went to the brightest star, which is almost always this target. The Landolt fields seem to be pretty sparse fields, probably on purpose, so that they'd be an easily identifiable star to all the world's users that have reference to this data. So anyway, raw instrumental magnitude equation, and trying to correct what we have measured, the G in this case and the R, into out of atmosphere. So it's sort of the first step in getting rid of the atmosphere. Okay, so there's an equation for each filter. The R0, I0, all these four will be corrected outside the atmosphere once it's done. This is a plot of the raw instrumental magnitudes over here against the air mass. And I was tickled pink to see that all these data lie on a nice clean straight line. Even though there's only 5 points, or 5 points on each line, they're all well behaved. There's not a huge range of air mass, but that works too when the data is so clean. And that tells you that, number one, the night was clear.
Yeah.
And that it was always clear. So
that's pretty amazing. That's really good.
It's excellent data. If there had been a cloud anywhere along the way that we're looking through, one of these points would have dropped out of the bottom.
Yeah, that's phenomenal.
So
Rick, suppose
that's
what
really
if there's some cirrus, some very weak cirrus? Does that
really
mess up the aerosol content or
component? It trashes the data big time. Yeah. Even thin cirrus is worth several tenths of a magnitude at least, and probably several magnitudes at worst.
Yeah.
And in fact, one of the points that was in this group of data did show some cirrus, and it was, I've chosen not to use it because I know it's no good.
I see
That-
Russ
that's
has
a-
his hand up.
That takes the point off of your linear curve.
Well,
with
yeah,
air mass.
it would be way down here, for example, and
Uh-huh.
it would bias the slope and all that.
Yeah.
Russ,
Now, if you think about it,
Uh,
the slope,
Russ,
oh,
Yeah, excuse me, I've got to run. I'm going flying and I got to leave for the airport.
okay,
good.
all right.
Okay,
No,
but
no
good
cirrus,
meeting.
no cirrus for the flying.
Yeah, right. Yeah,
Or no-
good meeting. See y'all later.
Bye-bye. So now the important thing about this plot is the slope of each of these curves. The slope, if you think about it, is the extinction combination of the first and second order terms in the correction equation. And the intercept at 0 air mass is what we would project the magnitude to be if it were outside the atmosphere. So this curve tells a lot about what's going on. Okay, then the process is to do this for a red star, a red standard Landolt star, and its G minus R is about 1, which is, it's quite a bit different. And it's difficult to find red stars that are constant, so that's why he's chosen relatively few of them, but they're important. And then do the same thing for a blue star, the same process, and those are nice and clean also. Now the difference in these slopes and intercepts tells you something about the color effects, right? So the next step in the process is to determine, I won't go through the equations or whatever, but basically we come out with the second order term as really small, which it typically is in each filter. And the first order term, you've got a version of it from the red star and a version of it from the blue star. And all I did, they're close. They're not exactly the same. And I'm not sure if that's a astrophysical difference or an atmospheric difference or just noise. But all I've chosen to do is to say, okay, it's the average of those two. And within, a couple of millimegs, it's pretty close. That's really nice. Okay, so we've defined the atmosphere, and you see that as we expected, the first order is higher in G, and then it gets less in red and lower in I, and it's about similar in Z. Z is kind of a problem because you're beginning to get into, I think, the water band absorption, and that observatory is close enough to the ocean that there might be a little humidity, a little salt spray once in a while. I don't know, but it's not a super dry all the time atmosphere. I'll bet. Okay, so those data are the goal of this whole extinction measurement process. And what I hope to do is to get a couple of more nights in November with the similar or other stars and get similar results, and then take a kind of combined average of 3 nights worth of data and say that's the best atmosphere we have. That's what happened. Typically the K prime will stay pretty constant. It's a small correction anyway. And from night to night, the K double prime will stay constant. The K prime will move around a little bit depending on, haze or smoke or whatever else might be going on. So we'll just hope we come out similar. Okay, the second process then, having these, we can correct any other data for the atmosphere on that night. And so that's what I've done over on this other sheet. Again, here's a bunch of ADUs, and I haven't even finished all the data yet, but these with numbers in them are the ones I've done. And typically these are any other standard star, and it was a great night because I got like 18 other stars observed all in the same night and mixed in together with all that extinction data. So this was a perfect night for for this process, plus a bunch of other data from other, other programs. The telescope really pumped it out that night. For those that I've chosen to reduce so far, I'm not sure what I was going to say there. Oh, it's important. I had to use different exposure times because some of these stars are pretty faint. And the first round in September, some of them they just weren't exposed enough. So I've used 5 and 10 and 15-second exposures, depending on their basic brightness. And so that needs to be corrected for, and I chose to just normalize them by that and have basically use the gain and turn it into electrons per second as the basic signal that's comparable to all the stars. And then here's the air mass. They're all observed near the meridian, which is nice. That minimizes the correction size that we're going to use. Except for this guy, he was observed way down low at 2.6 air masses. So I'm not quite sure how he sneaked in there, but anyway, I'll show you what what effect that had. Here's the instrumental G-R color index that I've chosen to use as the basis. And I could do this all the way over again for G-I or G-Z, which have, wider wheelbases. And yet I figured not to do that because the Z is getting pretty dim. And I wasn't sure whether the signal to noise would be good enough, but so far it might work. Okay, so here's the G data, here's the R data, here's the I, and the Z is off to the side. Anyway, this is the kind of the bottom line as far as I've gotten before. Here's the out of atmosphere corrected, get rid of the atmosphere, and it's the 0 data for each filter as opposed to the Sloan standard magnitude in that filter. And again, I'm tickled pink that the data is pretty close to a solid, nice line. And you see these points on the end over here happen to be the ones that were observed at 2.6 air masses. So they're a little off base, and I'll probably throw those away in the final analysis just because you can see in the images that they're very fuzzy, having looked through twice as much air mass as necessary, more than twice. It's good to use that high air mass data for the purposes of extinction, because that's what you're looking for, is how much does it matter. But it's for correcting data and ultimately speckle data, it's a problem. So we'll throw those away. But anyway, here's nice string of pearls data that really has high confidence. And the slopes of those plots are very close to 1 because the filters are a pretty close match, and the silicon in the CMOS chip is a pretty close match to the silicon in the SDSS chip long ago. Well, I guess it's still the same sensors. So everything's reflective optics is still reflective optics, and everything is a good match to the original. So the corrections are what, 5% for the green and 7% for the red and 6% and then 5%. They're all wow, pretty moderate corrections, which is nice. I've done this before with non-standard filters corrected to some standard system, and you get 20-30% corrections, which are bigger because the bigger the correction you make, the more likelihood it is to be off a little bit. But these are pretty small, so that I'm thinking that's going to produce some pretty good data. Anyway, I haven't finally got to the last step of how much different are those than the standard magnitudes, but that's the last step that sets kind of the so-called 0 point of the data. So I'm still working on that. Mm-hmm. Anyway, it's very promising so far.
Round of applause.
Yeah. This is great. Great
this
work.
This
Rick.
is
This is very
yeah,
good.
if we want to do precision photometry with these telescopes, I think we have to go still in more detail and tease out the finer details to get down to the level that Arnie would like to see. Maybe. I don't know about that, but I think that's possible. And he may have some suggestions, but I'm not ready to go show him any of this yet because he'll find too many mistakes.
Yeah,
But the
but
purpose-
this I mean this adds a lot of value, right? Because we can now do where we have binary systems that that contain a variable star, we can add that to our sets of measurements. You know,
Right.
we can really
Well,
do that.
Once this is all wrapped together and pretty much summarized and finalized, then these corrections will stay the same for anybody else's programs for several months at a time, at least. Probably a seasonal adjustment. We need to check it every few months, but it shouldn't change very much. And
what is that?
it'll once it's processed and put on the same standard system, then it'll be comparable with anybody else's data in the world, including the professionals.
I forgot which system are we on this? Is this?
This is Sloan.
But I mean, is it
Oh, this is the 1 meter.
the 1 meter? Okay.
Yeah, the
Right.
24-inch has the regular photographic
Right.
filters, which are not photometric. They could be corrected this same way
Yeah.
pretty accurately, but I've started with the ones that I want to really use
Okay.
for the speckle photometry mode. And in the speckle photometry game, the real essence is getting the corrections between filters, not the absolute perfect match to the standard system, but only close enough to get the filter increments, the color indexes right. So this will be really high quality data for that purpose.
I'm curious, the seasonal impact. What causes a seasonal impact?
I don't know.
The majority of it is aerosols at that time. For example, wintertime, you get a lot less aerosols than you do during the summer,
Okay.
provided you don't have any anomalies like fires and
Yeah.
strange things like that.
Volcanoes and
Yeah.
Okay, that makes
stuff that throws dust in the air and it's such fine particles that it doesn't come down for years
right.
or months.
Well,
Yeah.
and also it's you have more moisture. You can hold more moisture. Yeah. Okay.
Yeah.
Okay.
We're pretty lucky because we're doing most of our imaging really up near the meridian. So you're seeing very, very low air mass, which is great. If you get down low, well below 60, basically 60 degrees or 2 air mass, you end up having to change calculations because the air mass is not calculated the same at all. There's a whole bunch of factors that go into that, down to about 3 degrees and then 3 degrees down. You know, it's just, it's crazy, but we're lucky. It's a good job there, Rick.
Well, it seems to be working so far. That's great.
Yeah, it looks beautiful.
And those lines are amazing, truly amazing.
If one interesting thing was if I took out these endpoints, which were high air mass, those 4 were there. These numbers, the correction factors drop down to the 1 or 2% range.
It'd be interesting to see what your R² values turn out at.
Yeah.
When you remove those, you're just going to get closer and closer to 1.
The green was 9999.
Yeah.
Is that right? Oh, wow.
You can't do much better than that.
Huh.
And 1.5% correction. So it's pretty much a perfect match to the system of SDSS. Anyway,
very cool. We will highlight that in the newsreels.
I think you should also, Rick, submit when you finish this work, submit it to the AAVSO journal as well.
Yeah, we can do that. It's worth the paper, even though it's been done 100 times before. And most of the AAVSO the CCD AAVSO people are doing this same thing, you know.
Well, the fact that it's CMOS is really that'll be important.
Yeah. Well, relatively fewer people are doing it with CMOS yet, I guess, but that's coming.
Yeah.
And even fewer in Chile. So you know, there's some really positive aspects here, and it starts putting us on the map as far as being able to do photometry as well.
Yeah, that'd be almost critical, to be able to
Mm.
publish subsequently, yeah.
When when people are doing exoplanet work and stuff like that, the extinction is going to have a pretty major effect on the shape of the eclipse curves.
Yeah.
So it should improve data to correct that data as well. Should be an improvement to it. The only thing we have to do is to spot check the extinction each night we're going to do photometry, and we can do that just with basically any standard star by observing it several times at different air masses and see how it plays. We don't have to redo all the blue and red combinations and get lots of points on the curve. We just spot check to make sure it's still a clear night.
Yeah, that's basically it. We could do lots of binary star programs, as well as obviously with the exoplanets. It'll be a huge help.
Yeah.
I mean, we could do a lot of stuff that we just add in, we just plug in, like you were saying, the plug.
It's really a good idea
doing.
It's really a good idea for eclipsing binaries when you want to get the times the minimum.
Yeah, that's what I meant to
correct
say.
all the data, because otherwise it can misshapen and shift your minimum.
Yeah.
Just
So we could do a
subtly
speckle
shifted
program.
it.
Yeah, we could do the speckle program the same night that there's a planned eclipse of an eclipsing binary, and just do lots of measurements at the same time.
Yeah,
That's true. How do you account for then non-perfect observing conditions from night to night?
well, you probably just don't do photometry on those nights.
Okay.
Unless there's a particular reason to do that, like you're after a particular, let's say it's a binary eclipsing binary, for example. You're kind of stuck on that unless you go to the next period. So,
Right.
You can still use that data for very interesting things, star spot follows, and a lot of other stuff, mass transfers.
Is there a way to, or is it too variable? Is there a way to just use those to do some spot checks like you were saying, and then adjust it further for the conditions that night, or is that too unreliable?
I think that's possible on eclipsing binaries where, the main primary star is, forever about the same measurements. You can do lots of measurements outside of the eclipse time. And then even on the night, if it was damaged by the atmosphere, then you could do some adjustments. You can say, well, hey, last night it was perfect. It was magnitude 2.15. Tonight it's gone up to, 2.9, 3, 4, whatever. And you could then adjust it, because then the following day, do some more measurements when it's good again, and it'll be back to the same. So I think you can definitely do some, especially if you know what with these transformation coefficients, you'd know what the impact was, and it would be all relative, right? Everything would be out by a similar proportion based on those coefficients, right, Rick? So you could do some adjustments.
Yeah, you as long as the problem with variable extinction is that it changes through the night potentially.
Yeah.
When it's not really clear. So if you don't continuously monitor that, you don't know when the clouds appeared or when the haze came in, and it's hard to know what data to correct how.
Yeah.
But if you have an eclipsing binary pattern, you'll see that in the data. You'll see lumps and bumps and things, and you can probably pick out the points that need some fixing.
And you just keep doing observations.
Approximately.
Yeah, you just keep doing observations and make sure that you have hopefully enough good ones.
Yeah.
Most of my work in eclipsing binaries has been around contact or over contact binaries, so EBs or EW stars. And if you've got bad nights, if your science is to do something like try to find third bodies washed out for O-C changes, then you just don't include that data if it's going to skew your numbers, because you're on a long-term project. You're not on something that's one night to try to calculate masses between the two or anything like that. So
yeah.
Okay.
If there's data that it's only it's a nearly one day or multi-day period, and you only have one chance a month to get that eclipse, then you kind of have to use it, and you can pick and choose
Yeah,
judiciously what
data sets.
points to fudge and what points to throw away.
All you do is you
Always-
identify that in your paper that you're writing up.
Yeah,
it's
you just
tight,
gotta
and you say
Be
it.
honest about it.
Right. Right. Well, good discussion. Anything else before we should, it's hour and 15, we probably should try to,
Yeah, we
Cut it off.
overshot.
is there anything else?
Nick, I'm gonna have a couple of suggestions that you might wrap into the code for next time around if you're up for it.
Yeah, please feel free to email me any suggestions and things. I'm glad it worked until now.
Yeah, I appreciate all your work because it really has
Yeah.
worked beautifully so far.
Yeah, I'm really glad I got that just center on the brightest star thing in it.
Yeah, that
Yes.
made all the difference. Only three of the 18 it missed them because there must have been another brighter star in the field.
Yeah, I saw there was one where there was a bright star right at the edge, which was also kind of smeared out because it was at the edge. So yeah, that was bigger, so it shows that. So, but yeah, I'm glad I got that in there because
Yeah, that
otherwise
really-
a lot of the data couldn't have been gotten.
That really saved us a month.
Yeah.
What's the status of the plugin? Is it, what one should we be using at this point?
Just use the latest one. Just update to the latest one in the plugin. There, if you go to the plugin tab and click on the plugin where you see the options. There, if there's an update thing there, then use that. It actually might be good for you to use it on Barrow as well.
Yeah.
Because if you use the calculation, it'll try to plate solve, and then if it fails, it'll just grab the brightest star in the field.
Nice.
And
Okay.
hopefully that'll be the correct one.
Yeah. Okay. No, I've not used that yet, and that would be very helpful. Yeah.
Yeah.
Right.
Okay.
I'll have a file structure system to propose next meeting, and I'll show you all that along with the tool to generate the file structures.
Oh, good.
Yeah, that's just about done, by the way.
Excellent. Excellent.
Right.
Okay.
All right. A lot going on. See you guys next week.
Yeah.
Okay.
See you
Bye.
next week.
Stay in
Take
touch.
care.
Bye.